This man proved that the area bounded by any smooth convex curve and a secant line cannot be represented as an algebraic function of that secant, a result known as his namesake theorem about ovals. Samuel Pepys posed a namesake problem to this man regarding the likelihood of rolling sixes from certain numbers of dice. This man devised a thought experiment examining the different paths a cannonball fired off a mountain would take at varying velocities. The discovery of calculus was hotly disputed between Gottfried Leibniz and this man. For 10 points, name this scientist who apocryphally conceived his theory of gravity after an apple fell on his head. And the answer is Isaac Newton. Bertrand Russell criticized this man's approach to mathematics in a work titled The Teaching of This Man. One work by this man is preserved only partially and in Arabic. That work is his Divisions. A square three-dimensional array of line segments is known as this man's orchard. His best-known work includes a proof of the Pythagorean theorem and a fifth postulate that implies requirements for two lines to be parallel. For 10 points, name this Greek mathematician who wrote Elements and is considered the father of geometry. And the answer is Euclid. This man names a system of non-SI units in which the constant in Coulomb's law is exactly 1, and electric and magnetic fields have the same dimension. That system includes a unit equal to 10,000 teslas that is named for this man, which measures the strength of magnetic fields. A law sometimes named for him states that the divergence of the magnetic field is 0, forbidding the existence of magnetic monopoles. That law is one of two named for him that are paired with Ampere's and Faraday's laws to form Maxwell's equations. For 10 points, identify this German mathematician who names an improvement to Coulomb's law for calculating electric fields. And the answer is Carl Friedrich Gauss. As recorded in his Tusculan Dispositions, Cicero rediscovered this person's tomb, which is often confused with a dove house by modern tourists. The Fields Medal bears the image of this person, whose palimpsest includes a proof of the volume of a sphere using levers, whose mechanics he pioneered. A soldier from Marcellus's army killed this person after a siege in which he used grappling hooks to protect Syracuse. This man's screw is often used to move water upwards. For 10 points, name this Greek who discovered his principle of buoyancy and ran through the streets naked, shouting Eureka. And the answer is Archimedes. This man formulated the law that two identical objects have exactly the same properties in his identity of the indiscernibles. This man divided truth into necessary truths and contingent truths and claimed that the world exists in pre-established harmony in his Discourse on Metaphysics. This man believed that all composite matter is a representation of simple substances called monads. This man's theodicy uses the principle of sufficient reason to show that we live in the best of all possible worlds. For 10 points, name this German philosopher who co-discovered calculus with Isaac Newton. And the answer is Gottfried Wilhelm von Leibniz. He's not Torricelli, But this man names a point P in acute triangles for which the sum of the distances from P to the vertices is minimized. This man's namesake numbers have the form 2 to the 2 to n plus 1, and he names a statement that for a prime P, then P divides A to the P minus A. One of this man's statements was proven using the Taniyama-Shimura conjecture by Andrew Wiles and states that there are no non-trivial integer solutions to the equation a to the n plus b to the n equals c to the n for n greater than 2. For 10 points, name this French mathematician with namesake little and last theorems. And the answer is Pierre de Fermat. This mathematician extended the much earlier result that all numbers of a particular form are perfect by showing that all even perfect numbers take that form. He was the first to prove the infinite sum of 1 over n squared equals pi squared over 6. The simplest Runge-Kutta method is the first-order method of solving differential equations named for this man. The constant given by the harmonic series minus the natural logarithm at the limit is named for this man and Mascheroni. This mathematician names the identity e to the I pi equals -1. For 10 points, name this 18th century Swiss mathematician who named the base of the natural logarithm e. And the answer is Leonhard Euler. A result named for this scientist can be proven without omega consistency by using Rosser's trick. 2 theorems named for this scientist involve constructing systems that allow for his namesake sentences to be generated. Those theorems named for him can only be evaluated from a meta-mathematical level. The fact that the continuum hypothesis cannot be resolved in Zermelo-Fraenkel set theory is often credited to this logician, who demonstrated that every consistent system of axioms admits statements that are true, but which are unprovable. For 10 points, name this Austrian mathematician who names an incompleteness theorem and whom Douglas Hofstadter discussed along with Escher and Bach in a work of popular science. And the answer is Kurt Gödel. This person and Richard Taylor co-authored the article Ring Theoretic Properties of Certain Hecke Algebras. Helped by a paper on the Eisenstein ideal by Barry Mazur, this person matched modular forms to elliptical curves. That work was noteworthy because of a proof of the epsilon conjecture by Ken Ribe, which increased the notoriety of the Taniyama-Shimura conjecture. For 10 points, name this man who proved that there are no integer non-zero solutions to the a to the n plus b to the n equals c to the n for n greater than 2, which is Fermat's last theorem. And the answer is Andrew Wiles. When the type of matrix named for this person is left multiplied by a skew-symmetric matrix, the result is Hermitian. This mathematician's name comes second in the name of the theorem stating that each square matrix satisfies its own characteristic equation. This person is credited for the Icosian game, which involves finding a cycle on a dodecahedron that visits each vertex once, which is why graph cycles, which visit each node exactly once, are named for him. He carved one of his equations into Brougham Bridge in Dublin after being inspired to discover it by a walk over the bridge. Name this Irish mathematician and physicist who developed the concepts of tensors and quaternions. And the answer is Sir William Rowan Hamilton.